So now that we finished talking about the explanation of the critical angle, which only and only happens when a ray, such as light ray, is traveling through a medium with higher index of refraction to another medium which has a lower index of refraction. Such an example that we talked about
Mm,
last, if the ray is going from glass to air, and if the critical angle happened to be theta c, any angle higher than theta c will experience a situation which we call the total reflection, which basically means the ray is going to get trapped inside the medium with the higher index, and it's
mm,
never going to be able to escape. Now we're going to talk about how to calculate that number. So there's an equation for it, and we're going to calculate the equation to calculate to find out about theta c is this: sine theta c is equal to n2, the medium with the lower index, divided by n1, the medium with the higher index. So
mm,
let's go back to our example. Actually, let's make an actual example with numbers. So we're calculating the critical angle for a ray that is traveling from water to air. Okay, so first the condition is met. The ray has to travel from higher medium to lower medium. That's only when we have a possibility, not all the time, we have a possibility to get total reflection if the angle of the ray happened to be larger than theta c. So
mm.
now, first thing is we have to find out what theta c is, and then we can say if it's lower than that or higher than that. So in this case, we're going to talk about, let's say, water, and we're going to use this equation as well, sine theta equal to n2 over n1. So we have some knowledge. We want to calculate the critical angle for the light passing through water with the index of refraction of 1.33. So our N1 is equal to 1.33, and that's water. And we have, it's going from water to air, which has an index of refraction of 1. We can assume it's 1, or sometimes it's 1.0003.
Mhm.
With a good estimation, we can say 1 and 1.33. And the situation is that the ray, let's say it's the surface of water, and the ray is coming from water and trying to go through to get to air. Now we're going to talk about is what is the angle that if we happen to get that angle, what is that angle that we will start facing total reflection? Or in other words, what is the angle that anything higher than that angle will experience the total reflection? The equation we're going to use is theta c equal to n over n1. So sine theta c. N2 in this case is the second medium, the lower medium, the one that light is trying to enter to, or the ray is trying to enter to. So that's air in our case, 1.0003, and then N1 in our case is 1.33. So if we do a quick calculation, dividing 1.0003 divided by 1.33, we get 0.75. And the next step, if you can help me calculate it, would be sine inverse of 0.75 would be equal to theta c. So this is the equation for arc sine or sine inverse. Basically,
Mm,
you put the sine inverse in your calculator, which is usually used by arc sine or sine to the power of -1. And then you put the value of the sine, which you know, and then the calculator will tell us the angle. And if you do that, you get what angle?
uh, 49 degrees.
49 degrees, exactly. So we get theta c is equal to 49 degrees. So this is our critical angle, meaning if the light happen to be set in a very specific situation, such as what? Such as someone, let's say, if someone is swimming here and trying to have a flashlight or trying to send some signal, and then if the direction of the signal, either if it's a radio wave or water wave or light ray, if the signal is, let's say, has an angle of incident equal to 50 degrees, which we know we have the knowledge that the angle of critical angle is 49 degrees, and theta I in this case is higher, we can conclude that this light is not going to pass through the water in that angle, in that specific angle. Okay, we always have to keep in mind that this signal could be also sent in a different angle, like this angle or this angle. We're not saying it's impossible to send signals outside, but if you specifically want to send a signal in that angle, and why would you want to send a signal that way? Because maybe there's a boat here and someone is like sitting here and you want to send a signal to this person to get help. Now, if that angle specifically happened to be more than the critical angle, the light from your flashlight or the signal is not going to pass through the water, and it's going to get trapped in the water and experience a total reflection. And in that case, we know that the angle here would also be equal to theta r equal to 50 degrees, because now we're following the reflection law. Reflection law says theta I equal to theta r equal to theta r. So if we are ever asked to calculate the reflected total reflected line angle as well, we can do it with the use of the law for total reflection, or the law of reflection, which says the incident and reflection ray are having the same angle. And again, just a reminder, all the angles are always measured with respect to normal line. So sometimes we may make a mistake to sometimes consider this angle, which is incorrect. All the angles we ever talk about in this topic related to refraction, reflection, total reflection, any angle that is involved here, it's always with respect to normal line. And normal line is the perpendicular line to the direction of the surface of your object.